G'day comrade subscribers. So I've started pulling out the dodgy DRAM. So I've got two out. Here's one. Yeah, as I would love to keep them whole, but it's just not possible because there's a layer of varnish or something that they've coated both sides of the board with, which makes desoldering incredibly difficult. In fact, this is the second one I've just done. I've just clipped it and pulled it out. I did the same with this one, but I initially tried to desolder it, but you just end up damaging the tracks. The tracks start lifting. So the only way to reliably, if you want to protect the board, especially with Soviet era boards, is to just clip the chips and pull them out. Anyway, so it's definitely fixed the problem. Data in pin 2 and data out pin 14 are actually connected together on the board, which you can see here. Data in pin 2. See, I've got to really push down to get through the varnish layer. And now that it's been removed, so that's 5 volts there. It's no longer being pulled high. If we have a look on, so this is another dodgy chip. Pin 2, get through the varnish layer. There you can see 23 ohms. Whereas if you look on a working one, this one here, pin 2, and then 5 volts, nothing. Well, 350 ohms of impedance. So that's definitely the issue. Now that I've pulled it out, because obviously, as I said, data in and data out connected together on the board. So I thought it might be interesting just to check which one was actually causing the problem. Was it both, or was it one? So if we have a look at pin 2, and that's power there. So data in seems to be okay. If we have a look on, was it 16, 15, 14? So I don't know if that's going to make any difference. Oh yeah. Did that go? Yeah, I think there was some sort of yeah. So it's the data out. It's definitely data out. Yeah, 25 ohms there. So it's the data out pin that's causing the problem on these chips. Data in's fine, as well, it's open circuit according to this. Well, if I'm pressing down hard enough to get through the varnish layer, yeah, there's no connectivity at all between data in and 5 volt in the power supply rail. So there we go. So I'm going to get these other two dodgy ones out and stick some sockets in, and then try some 64 kilobit chips. So the secret with converting a 64 kilobit to a 32 kilobit is to pull the A7 pin, which is supposed to be, I think, this one here, pin 9. I'm going to pull pin 9 high. Is it already pulled high, or where does pin 9 go? Don't know. So I don't know, pin 9's going off somewhere at the moment. Oh no, I'm looking at the wrong one. It's pin 8. According to the data sheet, it should be pulled high already. I don't know where that's going, unless they've pulled it to ground. Pull it to ground? Where have they pulled it to? Let's have a look at that. Have a look on the schematic. Anyway, yeah, we'll see. Got to get these two out and see how we go. Right. After some effort, I've got the old ones out and I've got new sockets in. I've tested them. They should all be, because I did have problems getting them out, but they should all be continuous with where they're supposed to be continuous to. I've also checked the data in and the data out pins are all connected. So now it's just a matter of trying. So I think that I got these from AliExpress, so it's like, yeah, okay. So I do have some 64 kilobit, so I think I might try these ones here. They look to be okay. I do have some Sovietsky ones. I think these ones have pulled out. No, they're not Sovietsky. Maybe, what have I got here? Oh, I got some more there. So, I'm going to give them a try. One interesting thing, like, hang on, let's just put this up here. I'm not very confident, but like you guys said, so stick in a 64 kilobit, and actually according to the data sheet for these Soviet ones, it says for these particular ones to pull the A7 pin high. But interestingly on here, on this particular machine, the A7 pin is actually connected to, I think, one of the muxes. You have a look on the schema, you look at the A7 pin, which is pin 9, it is actually connected through. I think it's connected through to this one here, this multiplexer here, D18, pin 12. So yeah, I'll just stick them in, and I guess we'll see what happens. I guess I also need to wire up my little video output, baseband video output board as well, thanks to PCBWay, so I can maybe see if I get a signal this time, or if I've got some other problem. I guess the easiest way to check will be as if the well, I can check the data lines, make sure the data lines are okay now, but definitely, well, let's actually stick 4164. I think I can just stick these in, can't I? So now, if you're asking why I've used the turn pin sockets, it's because I really needed them in this case. Because like with this varnish layer, it really made it difficult to clear the holes out. So I really wanted these, really wanted to use these turn pin. So we've got this, like this little landing thing here. I can really push it into the trace. That's why I'm using them. So now, what we had before was the problem manifested before was data in pin 2 and data out pin 14 were pulled high, which they no longer are. So these chips are okay. Surprise, surprise. Well, they don't have that same problem that the Soviet ones have. Alright, so I'll do this. I'll wire that up and we'll see what happens, I guess. Alright, so it's been a while since I tried this last. Right, so we need video, okay, video out. CRT-C I've got, so the CRT controller, character data, and then 5 volts and ground. So the character data, so this is the video output here. So the character data, well, not, sorry, the CRT controller, horizontal and vertical retrace go into D6, and then into inverter D11, and then out to R19. So that's where I picked it up last time, R19. So D11 is this one here. So the output from pin 6 goes to R19. So I need to figure out which one R19 is. So pin 6, there's this one, well, there's this one. Alright. So that's the CRT-C connection, and then this must be the character data. So character data comes out of the ROM. So character data comes out of the ROM here into D11 as well, coming out of pin 10. So, and into R19. No, actually, yeah, they've got R19 listed twice. That's what kind of confused me the first time. I think that's definitely an R19. So that's character data, so the actual characters from the ROM, and then horizontal vertical retrace from the CRT controller. So that's pin 10 going into the other resistor. So So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be going up to this one here. We're getting through the varnish. I got the right one. Maybe I didn't have the right one. Oh, there we go. Yep. Alright, so that's the character data. They get combined together and we magically get a video signal. So I've got my very simple composite / baseband video tester, so I can just hook this onto where I think a baseband signal might be and plug it in to see what happens. So I'll just use this quickly. I have bought some, so this is the connector we've got at the moment, but I have bought some RCA jacks that should hopefully, I should be able to replace that with, and that's our cassette. So that'll be the next thing, try and load some software. So I've got this 5-pin header, so I'll hook it up, power it on, and see what the next problem is. Okay, so let me just start. So I've got my little video output stage here, and very dodgily connected up to an RCA cable via alligator clips, and that goes into this composite to HDMI, and then I've got HDMI to USB into my computer. And let me start recording. So, hey, but it's booted now. I just get rubbish on the screen. And obviously this is not the ideal kind of video connection, so, but I'm getting video output now at least. I wasn't getting video output before. So let me just power off again. Okay. And power on. Okay. Nothing. Very temperamental. Wow, that's probably the first time it's actually output anything for a few decades. No, we're not getting anything now. Right, power off again. And power on. No. Alright, not getting anything now. Okay. So, we're making progress. I don't know if my video output stage is, well, like I say, I'm using Sergey's design for his Radio 86 design. So it basically just mixes the controller, the CRT controller output with the data, with the video character data output. It works fine on his machine, so it should kind of work fine on this. So it might still be some issues. I'll fiddle around with it a little bit more and to see if I can get it to boot again. Oh dear. I've not been able to reproduce that rather beautiful display. Just get garbage on the screen like it's not working. So the problem isn't with the DRAM, with these ones at least anymore. They're not going high. They are going up and down. But this DRAM here, D27, which is bit D4, which is bit 4, the waveform doesn't look like the waveforms aren't too crash hot on the data bus, but this one here looks different. Now I'm not gonna remove that one tonight. My other concern is that there is activity on, obviously there would be activity on the A7 address pin, so that might be fine on these 32 kilobit, I don't know, but certainly on the 64 kilobit that's going to cause confusion, I think. So let me set up camera with the oscilloscope, and you can see. I think I'll call it a night, and I'll have another think about it, I think. Alright, I think we're ready. So, actually, let me just bring the light back over here. That's alright. So if we have a look at the A7, which is pin 9, so this is on the 32 kilobit. So there is activity. So I'm just wondering whether I should pull that pin 9 out for those 64 kilobit and just pull it high. I think I'll have to do that. Now, for this, so if we have a look at the, so that's one of the signals on the data bus. So it's not too crash hot, but it's okay, I guess. No, I don't want to do that. Okay, so we look at the other ones. Okay. But then we look at this D4 bit. That one's looked very, very different. That's the D4 bit. That's the D7 bit. Alright, what about D5? D5's next to it. Last one. Oof, that looks horrible, doesn't it? Let me just pause it. Ugh. Yeah. That's D5. And if we have a look at D4, so I don't know. When I had the logic analyzer, it was happy. It was picking up a high at anything over 3.3 volts. So of course that doesn't mean anything. So I might stick the logic analyzer back onto it. Look at another bit. So yeah, so I don't know, maybe I might swap that one out as well. So I've got two things to do. So I've got let's have a look. So I might replace this one as well, D4 bit maybe, and I might pull out the A7 address pin and then just tie it to 5 volts. See if that fixes things up, because obviously I might get confused if we're selecting the wrong 32 kilobit bank. So I might do that as well. Alright, but maybe progress, Bye for now. Random. Let's start recording. So I have pulled A7 high on those 464 kilobit, just so I'll give it a try. And I'm getting junk again. So I'm getting some sort of output. But if I power off, it's quite random really. Power off. Power on. Am I going to get anything this time? No. If I pull that out, quite intermittent. So still another issue I need to sort out, I think. I'm definitely getting text. So one more power off. Yeah. Just thinking I should make a little daughter board, 32K daughter board, so I just need to put the 64K on and everything's taken care of. Actually, I would prefer just to replace this with a 32K SRAM, but then you've got the column and row selector to latch or something. Not getting anything now. Oh, okay, got some garbage again. Right. Well, it's better than what I got last time. So, okay. I'll have to have a think. Do some more investigation. See how we go. Alright, I'll start recording that. Okay. That's it for tonight. Bye for now.